Let's do a quick review of these unique triangles. So we said there's 4 unique triangle theorems. So the first one was SSS for side, side, side. Well, we have to remember that just because they have 3 side measures doesn't mean that it forms a triangle. We have to think about that the sum of the 2 smallest sides must be greater than the third side, because even if there's 3 side measures, if that doesn't work, then it cannot form a triangle. We have angle, side, angle, ASA, that stands for angle, side, angle. We have side, angle, sides, SAS. And we have angle, angle, side, AAS. And remember, the order matters, right? If we flip this around, that'd be something we shouldn't be writing on the paper. So that's how I remember that it order matters. This means a side, then an angle, then a side. In our unique triangle stations, we talked about angle, 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 but we discovered that it doesn't form a unique triangle. It actually forms what we call similar triangles. They have the exact same angle measures, but their side lengths might be different. So now we're going to look at applying the theorems. Given the following conditions, can you draw a unique triangle, more than one triangle, or no triangle? So basically, we're trying to figure out which of the 3 is true for each of these. So given triangle DEF, and I kind of just draw a sketch, and it does not have to be an accurate sketch. I'm just trying to kind of see what it looks like. So we've got DEF. Here, it gives me angle D, so I have an angle is 72 degrees. It gives me angle E is 96 degrees. And it gives me angle F is 12 degrees. So I am given angle, angle, angle. And I have to ask myself, was that a unique triangle theorem? No. It was actually what we just talked about, which said it forms similar triangles, which means we don't form a unique triangle, we form more than one. Example 2. Given a triangle with side lengths 10 feet, 12 feet, 15 feet. I could sketch this one out, again, just to kind of get an idea. We've got 10, 12, 15. I know that I'm given 3 side measures, which is a unique triangle theorem, but I got to make sure that these side measures work. So I'm going to identify the 2 smaller sides, which is 10 and 12, and my largest side, I need to make sure that 10 plus 12 is greater than 15. Well, 10 plus 12 is 22. Is that greater than 15? Yep. So side, side, side works. So this is a unique triangle. Example 3, triangle ABC, where angle A is 55 degrees and AB equals 4 centimeters. So I'm going to sketch out, I've got A, B, C. A is 55 degrees and AB is 4 centimeters. Well, we only have an angle and a side, which was not a theorem. This actually has 2 options that could be drawn. So it's actually not one unique triangle, it's more than one. And then the last one here, given triangle CUB, where CB is 10 centimeters, UB is 7 centimeters, and angle C is 115 degrees. Again, just going to sketch it out. CUB. CB, this line segment right here is 10 centimeters. So we're given a side. UB right here is 7, and we're given angle C, which is 115 degrees. So now I got to think about the order that's given to me. I have an angle, then I have a side, and another side, which I'm not going to write on there, right? Let's write it the reverse way. We have a side, then an angle, which was not a triangle theorem. So, no triangle. Or actually more than one, probably. Or you could say not enough information. So So now let's use this idea to figure out whether the triangles are congruent to each other, not congruent, or not enough information. So here we've got triangle QPR. We've got an angle, P, a side, and an angle. So we've got this angle has 2, and that angle has 2. We've got this side measure, and then next to it another angle. So we have angle, side, angle, which is a unique triangle theorem, which means that they both form a unique triangle, which has to be the same. So they are congruent. For example 6, we've got a side and an angle that are congruent to each other. So we just have angle, side, which was not a unique triangle theorem. So I'm going to say that we have not enough information. They might be congruent to each other, but we would need to know another side measure or another angle or something else to figure out if they are congruent. Then example 7, we're given, we've got an angle, we've got sides, and sides that are congruent. So we've got a side, and an angle. Was that a unique triangle theorem? No. So I would say not enough information. They could be congruent, but it's not a theorem that proves that they are unique, so we don't know whether they are congruent. And then the last part, being able to write to show that the triangles are congruent. So if we have triangle LIN, what is that congruent to? If we're saying these two triangles are congruent, how would we list it? It has to be listed in the specific order. So if triangle LIN started with L, we got to find out which angle is congruent to L, which is angle E over here. Then they had I, which had 1 curve, and A has 1 curve, so it's A that's congruent, which leaves us with N was the 90-degree angle, R is the 90-degree angle, so those are congruent to each other.